Hello there. Today we are going to start applying our skills of multiplying polynomials to actual perimeter and area problems. This will also get you ready not only for my class but geometry next year as well. You're going to start with the bell work. Take a moment to copy these two problems onto your notes. Go ahead and multiply, and then when you are done, come back and check your answers. How did you do? On the first one, were you able to get 5x squared minus 13x minus 28? That answer came from x being distributed to the 5x, which is our 5x squared, and then x times 7 is 7x. So we are done distributing the x, but we now have to take the negative 4 and distribute it. That would be minus 20x. And then the negative 4 times 7 is where our negative 28 came from. So take a moment. If you made any mistakes, go ahead and check them here and see what happened. On our next one, when you distribute x squared times 3x squared, if we multiply the coefficients 1 times 3, that's where the 3 came from. And then remember, when you multiply terms, you add the exponents. 2 plus 2 is 4. Next, we're going to multiply and distribute that x squared times 4x. Well, again, the coefficients 1 times 4 is 4. And then add the exponents. 2 plus 1 is 3. And then the last one to distribute is 1x squared times negative 9. 1 times negative 9 is our negative 9, and then x squared, because there are no x's attached to the 9 to add to it. Please take a moment. Make sure you have written the problems as well as the work and solutions. When you are ready, move on to the next slide to get your objective for today. Today's objective is that you are going to be able to find the perimeter and area of a rectangle with polynomial sides. If you could draw that picture in the objective, that will be one thing that I look for when I check off your notes. You will see the perimeter can be found by adding all 4 sides. We know that the length is 3x plus 2, and the height or the width is x plus 4. In a moment, we will get started practicing how to find the perimeter and area of an example just like that. First thing you do need to remember is that the area is the product of the inside. So notice I shaded the inside. So when we find the area, we are talking about the product inside. You may recall that the formula for finding area, there are several ways you can say it. Mostly you will see length times width, but you can also see it as base times height. Both mean the same thing. Now when we talk about perimeter, we are going to add all the sides together, and that will give us our perimeter. So for example, we have 2 lengths. So we have a length here, and we have a length here. So we could technically say we have 2 lengths plus we have a width right here and a width right here. So technically, if we want to get fancy, we can say the perimeter formula is 2 lengths plus 2 widths. The definition you generally know is perimeter means add up all the sides. So please take a moment to draw those visuals and examples into your notes. When you're ready, move on. Here's our first example. You have a square, and you can trust me that it's a square because both the length and the width are the same. They are both x plus 5. If we want to find the perimeter, that means we could add up all 4 sides. I could label the 2 remaining missing sides because a square means they are all the same length. So when you come over here to start showing your work, you could write it out the long way. You could say x plus 5 plus x plus 5 plus x plus 5 plus x plus 5 because there's 4 sides to the square. Or I'm going to guess some of you are going to say, well, Miss Bremser, there are 4 sides, then they are all x plus 5. So we could simply write it as 4 times x plus 5, because there are 4 x plus 5s. If you then use your multiplication rules and distribute 4 times x, you will get 4x, and 4 times 5 is 20. So the easiest way to get the perimeter for a square is to multiply 4 times whatever the length is. So our final answer is the perimeter equals 4x plus 20. Now area, if you remember, we just talked about the formula for area of a square or a rectangle is length times width. Well, in this example, the length and the width are the same thing. So we are going to multiply x plus 5 times x plus 5. So take a moment and multiply that out and see what you come up with. Were you able to come up with x squared plus 10x plus 25? That comes from distributing this x times x, which is our x squared. And then we have x plus 5, which is 5x, plus another 5x. That's where my 10x came from. And then 5 times 5 is 25. Whether you're using the square model, the box model, or you're doing distribution, you should still be able to end up at x squared plus 10x plus 25. Take a moment, make sure you are okay with perimeter versus area. When you're ready to practice a new example, move on to the next page. Same idea. This time we have a rectangle instead of a square. I'm going to hope for perimeter that you make your life easy. I am hoping that you will see we have 2 lengths. We have 2 2x squareds plus x minus 3. Instead of writing them both out, I am hoping that you will simply write 2 times the quantity. I have it over here. 2 times the quantity, 2x squared plus x minus 3. And then you will notice we also have the width right here, 3x squared minus 2x minus 5. We have not 1, but 2 of them because we have the other matching width over here. So we have 2 of this trinomial. So if you want to find the perimeter and make your life nice and easy, you're going to show me that you're going to have 2 3x squareds minus 2x plus 5, and you have 2 2x squareds plus x minus 3. Now, in order to go ahead and evaluate, you're going to distribute that 2. That would give us 6x squared minus 4x plus 10. I will now distribute the 2 to the other set of parentheses right here. That would give me 4x squared, and it is a positive 4, so I'm going to go ahead and put the plus sign right there. And then 2 times x is 2x, and then we have 2 times negative 3, which is negative 6. Now I've got to go back to my last section and remember how to combine like terms. X squareds, I have 6 here and 4 here. So altogether I have 10 x's that are squared. When I look at my x's to the first powers, I have negative 4 and a positive 2. That's going to equal a negative 2x. When I look at my constants, I have just a plus 10. Notice I'm circling the sign in front of the number. That's a 10 and a negative 6. So 10 minus 6 is 4. So the final perimeter is 10x squared minus 2x plus 4. Take a moment, make sure you're good with the perimeter. When we go to find area now, we're going to do length times width. The length is the 2x squared plus x minus 3. That is going to get multiplied by 3x squared minus 2x plus 5. Take a moment, See if you are okay. You're going to distribute a lot of times here. You're going to take your 2x squared and distribute it 3 times. And then you're going to take your x and distribute it 3 times. And then you'll take your -3 and distribute it 3 times. Take a moment, see how you can do, and then come back and check yourself. Please check, I distributed the -2 and I got 6x to the 4th minus 4x to the 3rd plus 10x squared. I now am going to distribute the x. That would give me 3x to the 3rd, which is positive. I am going to stack my like terms just so it makes it easier later when I must add them together. You could choose to write them out to the right as you go. X times a -2x is a -2x squared. Make sure you are adding the exponents. X times x is x squared. Taking that same x times 5, I will get plus 5x. I'd like to challenge you now to see if you can distribute the -3. It must get distributed 3 times. Pause the video. See if you can come up with the same 3 terms. When you distributed the -3, were you able to get -9x squared plus 6x minus 15? Once I have that, I must now add only my like terms together. There is only one term that is to the 4th power, so that is 6x to the 4th. When I look at my x to the 3rds, I have -4 plus 3, which is a -1x cubed. You do not have to write the 1, but you do need the negative in front of the x cubed. I'm going to add my negatives first for my x squared. That's -11 plus 10 leaves me with -1x squared. The x's are pretty basic. 6 plus 5 is 11x. And then there's only one constant that does not have to be combined with anything, minus 15. So we are ending with a 4th degree polynomial with a leading coefficient of 6. Take a moment, that was a lot. We multiplied a trinomial times another trinomial. Take a moment, let that sink in, replay if you need. When you feel ready and you're confident, move on to the next slide. Here's an interesting question that will have you working backwards. I'm telling you the area of the rectangle is x squared plus 6x plus 5. All I am giving you in the problem is the fact that the width is x plus 1. We do not know what the length is. So what I'm asking you is x plus 1 times what will get me to the trinomial x squared plus 6x plus 5. Take a moment. Sorry about the bell ringing. I was trying to avoid that. So take a moment. What can you multiply x plus 1 by that will have you end up with x squared plus 6x plus 5? I will give you a hint to get started. X times something must equal x squared. X times x is x squared. We are halfway done, ladies and gentlemen. If we picture distribution, x times x gives me the x squared. What I need to figure out right here is what number to put here. Well, when I get done distributing, the very last one is going to be 1 times something, which must equal this 5. Well, only 1 times 5 will end up equaling 5. So now if I visualize, x times x is x squared. X times 5, we'll go with a positive 5, but check ourselves. That will give me the 5x. And then 1 times x is 1x. Ooh, that does in fact add up to our 6x like we needed right here. And then 1 times 5 is 5. So a key thing to pay attention here is x times x does equal our first term of x squared. This last number needs to multiply by this constant to equal the constant on the end of the trinomial. That is a big hint you're going to use. Take a moment, process that. See how you feel about working backwards to find that the length is really x plus 5. This last question I'd like you to look at is to determine which one you think has a larger area. We have a rectangle that measures x plus 5 by x plus 3. If we're finding area, please remember that means you're multiplying length times width, which would be x plus 3 times x plus 5. If you multiply and distribute, let's see what you get. When you're done with that, come over here, and here's our square, x plus 4 times x plus 4. Go ahead and distribute on both, see what areas you come up with, and then we'll compare. When you distributed, did you come up with an area for the rectangle of x squared plus 8x plus 15? And then for the square, did you come up with x squared plus 8x plus 16? If you did not, take a moment to go back and find where your mistake is. When we compare, they both have just x squared. They both have 8x. Where they differ is in their constant. This one will add 15 to whatever our answer is, and this one will add 16 to whatever our answer is. So the original question says, which has a larger area? It would definitely be the square that has the larger area. That is because no matter what number we sub in for x, anytime we sub it into both of these trinomials, the second one with the square will end up adding 16 after you multiply it by 8 and square it, whereas the rectangle only adds 15 after it multiplies by 8 and squares it. Ladies and gentlemen, that is it for our area and perimeter lesson using polynomials. Take a moment, make sure you're good, look over your notes, make sure they're complete. If you are ready, you can come get your notes in class.